Hey, today me and my group are going to compare TensorFlow Pytorch by two datasets. Our group is Sanjay, Hegel, Susi, and Arif. We start a comparison with a well-known dataset which is called MNIST dataset. We have downloaded the dataset from the mentioned website. MNIST dataset is a dataset including a group of images that shows the numbers from 0 to 9, 0, 1, 2, 3, 9, and we are going to classify these images. First, we import our libraries, and we know that we're using the Keras API from TensorFlow library for classifying the images. Our images are 28 by 28 pixels, and the values of them, each pixel shows the value from 0 to 255. But we try to normalize this dataset from 0 to 1, and as you see, the single image shows the values from 0 to 1. And our wide range is our classification is from 0 to 9, number 1, number 2, number 9. After that, from the Keras, we use the functions contains, droplet, and dense. In the flatten, we just convert the 2D into 1D. In the dense, we learns how to deal with the nonlinear. And for the dropout, it's just drop out some 20% of neurons. And after that, we predict that. In the rest of the code, we just try to understand the accuracy and loss of our function to see whether our training and testing is going well. In the next video, we go and compare and talk about the accuracy and our plots in more details. So as of now, we just know that our epoch is 300 for all the modeling, and the accuracy shows the large values, and we see it's 99%.
Hello, this is Ripner. I would like to explain how we use TensorFlow and Pytorch using the MNIST dataset. We downloaded the dataset from this website. And then for the model structure, we try to make both model has similar layers, such as the first layer about 228 using the same activation function using ReLU. And then the second layer also 128, and the last layer will be 10 nodes because the dataset has 10 different classes from 0 to 9. And for the loss function, we also use same loss function, cross entropy loss, and for the optimizer, both use Adam optimizer. And the epoch number will be 300 and base size 64. And then during the after fitting the model in using the training dataset, the TensorFlow showed the loss of about 0.008 with accuracy 99.79%, and the total training time about 625.62 seconds, while Pytorch using the same epoch number 300 and showed that the loss about 0.559 with accuracy 98.1%, and the total training time is about 4,371.84 seconds.
Hi, this is Mengjie. I'd like to present the comparison between TensorFlow and Pytorch with our own dataset. We use JOT index dataset collected in Project 1. It consists of 4 features which are scaled into range 0 to 1 using scikit-learn scaler. The label is JOT level index, range from 0 to 5. Firstly, let's look through the TensorFlow code. We use Keras sequential to contain the layers. We built a simple model with 2 dense. For the first one, the input dimension equal to feature shape is 4. The output dimension is set as 64. Then we add a ReLU activation function after it. The second layer has 64 input dimension and 1 output dimension. Next, we select mean square error as our criteria, so we use mean square error loss function. In addition, we use Adam optimizer with 0.001 learning rate. For recording training time, we write a class to store and plot the training time. Then train the model by using fit command. We set epoch number equal to 300 and batch size equal to 64. Finally, we predict the test set to check the model's performance. Now let's go to the Pytorch code. The dataset is NumPy array type and pandas data frame type, which Pytorch cannot accept. So the first thing is to convert the data type to torch tensor. Then we use nn.sequential to contain layers. It used like Keras sequential, because the equivalent of dense in Keras layers is nn.linear. So we use it to build the two linear layers with same input and output dimensions, and add a ReLU activation function between them. Then set the same loss function and optimizer. There is no fit command can use directly, so we write a train function and use a loop to call the function to train the model. We also store the loss and the time during training. Finally, use the trained model to predict test set and check the performance. Now we can summarize and compare the two frameworks. We use the same training and test sets, same model and criteria. For the training time, TensorFlow takes slightly more time than Pytorch. Since we use a very simple model, if we want to train a very complex model with large epoch number, Pytorch will have significantly shorter training time. However, the accuracy of Pytorch is much worse than TensorFlow. I tried to change the layers dimension or add more linear layers, but the accuracy didn't increase. Finally, I'd like to talk about ease of use. Generally, I spend less time on TensorFlow when I did the assignment, because it's easy and fast to build a basic program with Keras and some useful common functions. But I also think Pytorch is flexible and I can create programs with many details which I want.
In the next part, we compared the TensorFlow and Pytorch by the AHP and TOPSIS method. To do that, we quickly decided that the criteria that are important in our decision are accuracy, training time, complexity, and loss. Based on that, we quickly made a matrix for the comparison of our criteria, as you see, and also we created a table based on alternative based on each criteria, and you can see that. We used the method AHP to calculate the weights for each criteria, and after that, by TOPSIS method, we ranked each of these alternatives. And one important thing about TOPSIS here is that we know that accuracy has a positive impact as much as it be bigger, it's better. Training time, complexity, and loss, all of them are negative impact. It means that as much as they be less, it's better. And then we use the TOPSIS to rank them, and the result shows that TensorFlow shows a better rank than in comparison to Pytorch. We assume that because maybe the TensorFlow has been in the market for a longer time and it's improved better, it shows a better accuracy and it shows a better performance. And this is our references, and thank you for listening.